Got another question on the redox titrations topic, and as always the link to the questions in the description of the video if you wanted to try it first. Okay, so we'll make a start. So we've got to complete the electron configuration for the copper species in these two compounds. So for the first one, we're told that it's hydrated copper 2 methanoate. So we've got copper 2 plus in here. You'll notice I've already written up the electron configuration for the copper atom. So we'll just refer to this to explain the electron configurations. So to go from the atom to copper 2 plus, we need to lose 2 electrons. We lose the 4s electron first and one of the 3d electrons. So that's going to give us that configuration there. And then moving on to the second one, it's copper 1 iodide. So we've now got copper 1 plus. We just need to lose this electron here, which gives us that. Part B, so a suitable copper compound for step 1 would be copper 2 oxide, copper 2 hydroxide, or copper 2 carbonate. So I'll do all three of those equations. So if you've gone for copper 2 oxide, the equation looks like that. Copper 2 hydroxide looks like that. And copper 2 carbonate looks like that. So moving on to part C now. So this is unbalanced at the moment. All I've done is summarise the information about step 3. We are told the ratio between copper 2 plus and iodine is 2 to 1. So we could just simply put a 2 there. Obviously that means we need a 2 in front of the CuI, and then to balance the i's we need a 4. So that's one way to do it. Alternatively, you could write it like that and you've still got that 2 to 1 ratio between the Cu2 plus and the I2. So moving on to step 4, so the solution you would add at the end point is starch. So I'll just quickly explain that. So remember, this reaction is carried out on the sample and it's generated iodine. So that's brown in colour. And then sodium thiosulfate is added to that in the titration, and this brown coloured sort of fades to yellow, and then ultimately it would just fade to colourless. And it's very difficult to see the exact point where the sort of pale yellow becomes colourless. So towards the end point, when it's sort of still a pale yellow colour, because there's a little bit of iodine left, you would add starch indicator. So even the tiniest amount of iodine present would make this starch go blue-black in colour, which is obviously very easy to see. And then when the magic drop of thiosulfate goes in and gets rid of the last bit of iodine, that blue-black colour will go to colourless. So that's your colour change. So moving on to the calculation now. So I've just summarised the information into a diagram. I've got the equations as well. We'll refer to those as we go through. So we'll just quickly talk through what they've done in the experiment. So they've taken 2.226 grams of this hydrated copper salt, and obviously it's gone into water and you've freed up the aqueous copper 2 plus ions. So there's the dissolvent equation. The important thing to note here is that the moles of copper 2 plus will be the same as the moles of the hydrated salt. So the copper 2 plus ions are then fed into the 250 cm cubed volumetric flask, 25 cm cubes taken out, some Ki is added, so that's the reaction that's going to take place. It's going to generate iodine, which is brown. You add your sodium thiosulfate via the burette, so that's your titration. So that reaction takes place there. And we know that the concentration of the thiosulfate is that, the mean titer was that. So first thing we can calculate is the moles of thiosulfate ions used in the titration, concentration times volume in decimeters cubed, 9.87 times 10 to the minus 4. Then if we apply the ratio, the moles of iodine that is involved in the titration, which are the moles of iodine formed in the first reaction, will be half that, 4.935 times 10 to the minus 4. So then if we apply the mole ratio in this equation, we basically go back to that original number of 9.87 times 10 to the minus 4. So they're going to be the moles of Cu2 plus in the 25 cm cubed used in the titration. So the moles of copper 2 plus in the 250 cm cubed of the solution will be 10 times what we've just calculated. So 9.87 times 10 to the minus 3. So let's just think about, where did these come from? They came from the dissolving of the hydrated salt and we established at the very start of the question that the moles of copper 2 plus are the same as the moles of the salt, so this is also the moles of the salt in the 2.226 grams. So that means the MR of the salt is going to be the mass over the moles, 225.5. So then if we subtract from that the MR of this part of the salt, that leaves us with 72 for the XH2O part. And then just divide by 18 the MR of water and we get X equals 4. Which means that the full formula of the salt is CuHCOO twice dot 4H2O.